indication where that was an indication that where we find the highest hydraulic heads and where the groundwater flow goes. That was the first step in order to know how the model should be behaved. The second was data related to chromium concentration. The chromium concentration, the maximum values of chromium concentration are different from one country to another. Here in Greece is about the 40 milligrams per liter, but if we take California and USA, it's the 5 milligrams per liter. We found concentrations in most of the areas more than 40 and 60 milligrams a liter, and this was mostly to the geogenic geological formation. And we find also outside the base some areas where the measurements indicate concentration for more than 160 and 175 milligrams per liter. But we were concentrated in the area of study, which was the basin of Asopos River. We did several geological sections in order to be able to describe the geology. And the conceptual model that we finalized was a 3-layer model, where was the upper layer with the geology, which was depending on different geological formation. And then below that, we had a layer of limestone and another layer of limestone. Actually, we created the model with 4,747 nodes and 8,992 elements. These are the first results that we got regarding the hydraulic heads, the behavior that we were expecting, and it was based on our conceptual model that we had created. And also, in order to verify the measurements and the model values, we did also a kind of hydraulic head calibration. And as you can see, we had an R-square of 0.96. And these are all the locations that we were concentrated. And why we are concentrating in this area? Because as you will see later, the problem which is created is in this area here where the industrial park exists. And this was the behavior of the groundwater velocities. As you can see, we have very low velocities, and that's a very good thing that it happens in the area. Due to the pollution of the chromium, then the small groundwater velocity helps in order to protect the area from spreading the chromium in a larger area. And this was the results regarding the concentration, the modeling results of the concentrations. The scale that we have here is from 0 to 200, but actually in this area where the industrial park exists, we found chromium concentration more than 3,000 milligrams per liter. And also we did a kind of calibration for the concentration results. And also we did the aquifer response under climate change scenario A2, was also investigated for the next 2 decades. Under this scenario, it's expected that rainfall and thus infiltration will increase by 7.7 during the winter and 15% during the summer period. The results for the 2 sub-scenarios, linear and variable precipitation reduction that were implemented based on A2 scenarios, show that the impact on the study aquifer is moderate, resulting in a mean level decrease less than 1 meter in both cases. So we have here the results, the average due to the climate change. We are expecting a decrease in the water table on an average by 0.5 meters. And this is also the behavior of regarding the spread of the chromium-6 concentrations for the 2 different. The main problem here, after finishing the big model, it was to be concentrated on the industrial area where the concentrations were not only 3,000, but went up to 10,000 in some locations. This is an air photo from the area of study, the industrial area. We found several, we had several sampling wells. The INO is the sampling well. We found some armed existing wells that were in the area, but also we found some pits indicated by SKA, which they were a few meters long, a few meters, very few meters in depth. That was the information regarding because the concentration of chromium-6 values detected in this location here, INO N6, where in May, it was in 2013, the concentration was 3,300 milligrams per liter. In November, when the rain started, the concentration went up to 10,000 milligrams per liter. And in January, where the concentration, the rainfall was reduced, then went back to 7,190. So it was an indication that the chromium-6 is flush when the water comes. We went for a more detailed model now using a FEFLOW, the FEFLOW, and we were concentrated only in the area where the industrial park is. This is one picture of the geology, very complicated geology if we are concentrated in the industrial park area. And this is an overview of the FEFLOW model. The blue level here shows the groundwater table. And this is the analytical geology regarding the surface that we can see. And the blue line here is the river. And all these blue and red lines here, the small blue and red lines here, are ejection and extraction wells. Therefore, there is a monitoring system which started in 2011 and still goes on. And now the concentration that they have been observed based on the model and based on all the collected data that they have, using all these wells that indicated here, are below to 100 milligrams per liter in all the locations. We did also some calibration of the new model, and the work continues with the remediation actions. And also there is a publication already regarding the big model. The small model actually, due to national involvement and some the local agencies that they are involved, the results cannot be published yet, but the big model has been already published in the Journal of Environmental Science and Pollution Research. Thank you for your attention.
Thank you, Professor Karagias, for your interesting presentation. The second expert, the second specialist is Dr. Maurizio Polemio. Maurizio Polemio is a CNR senior scientist, the head of Bari Department, the Hydrology Laboratory and the Hydrogeological Research Group of National Research Council, Research Institute for the Hydrogeological Protection. He published more than 200 articles in scientific journal. He participated in scientific committee and in national and international conferences. He was a person in charge of the National Scientific Secretary of the International Hydrogeological Program of UNESCO from 2000 to 2017. He was a temporary professor at the University of Bari and the University of Calabria of Engineering, Geology and Hydrogeology. And also he has obtained the National Scientific Qualification as a full professor of Engineering Geology in Italy. Dear friend, dear Dr. Mauricio Polemio, the floor is yours for your presentation.
Thank you. Thank you very much for the introduction, dear Kostas. I'm very happy to speak and to participate to this event. I will describe my activity concerning groundwater management. Just a moment. Is the first time that I use Zoom sharing the screen in with this computer. I need to restart the session. Just a moment, sorry.
Sure, how? Okay. If you need any help, I'm at your disposal. So, with sharing your presentation, okay.
It's just the first time that I use share the screen, and this computer required restarting. Okay, I am ready.
Okay, Mauricio.
Okay, so my contribution concerned the management of groundwater at salinization risk. The subject involved a very large portion of Earth's surface. It was assessed more or less the 16% of the Earth's surface can be recognized as in which there is no fresh groundwater, only saline or brackish groundwater. The source of salt are different, but the main one, approximately the 17% of this surface, is due to seawater intrusion. That is considered for this the primary source of salinization for groundwater. In this case, the dilemma for the managers, for person is as we are involved in the solve problems, is can be described from the between these three cases. Usually we consider the seawater intrusion as the fact of seawater intrusion that create a wedge of brackish or saline water below fresh groundwater flowing in the sea. But or for the fact of the climate change, or for decrease of the recharge, or for the fact of the increase of discharge, we can observe two different extreme situations. The first one, that is the recharge, is so high that the fresh groundwater is able to push out the brackish water, and so we have an aquifer completely full of fresh groundwater. On the contrary, if prevail the decrease of recharge during a drought period, for example, or for the increase of discharge for mismanagement, we observe that the brackish water completely for the aquifer, we observe no more outflow from the aquifer. So our capacity to use this kind of groundwater should be able to avoid the sea event, so discharging water is possible to avoiding the salinization of the resource. This is our dilemma, to discharge, but not enough to reduce the availability and the quality of groundwater. To understand in which way this situation was considered, was solved, if it is possible, worldwide, we realized a research in which the data were papers, mainly scientific articles. We selected 157 papers, mainly from an international journal, to study the approach to the risk of groundwater salinization worldwide. This map summarized the data set in which we considered one document for each country, if it is a subnational or international experience. Some of these documents are theoretical or not referred to some countries, but in any case, we consider roughly 500 documents or articles. Studying these documents, we were able to distinguish different approaches, different solutions that can be described in this way. The simplest approach is local. The main purpose is to obtain the largest amount of water, the highest yield, with a lower salinity. We called this set of approach engineering approach because generally our works realized in a very narrow area to tap water. So we can distinguish, apart from wells, some peculiar solution to obtain an optimization of the well design, to tap submarine groundwater, or solutions that were realized in different cases in the Mediterranean area with the horizontal tapping works, physical barrier, and so on. There is no time to describe all types, but I will show some examples that are underlined. Well, in this slide, when these solutions are not able to guarantee to avoid an increase of salinity or the sufficient amount of groundwater, more complex approaches are necessary to be applied to aquifer scale, to aquifer dimension. So we call this approach discharge management approach. They are based on the hydrological balance and demand assessment, trying to obtain an equilibrium between these, but also improving the recharge in an artificial way, reducing the groundwater overexploitation where it can be dangerous for salinization, studying the pumping pattern and so on, including monitoring a salinization vulnerability, about which I will show some example. But also this can be not enough to avoid the decrease of quality and decrease of fresh groundwater availability. In this case, we can move to the maximum complexity and effectiveness, applying a regional approach, where regional means not a region from a political point of view, but an extension that is able to involve also the management of surface water, with solution can be expanded from the improvement of the charge, use of other water sources, water use, and again, also the modification of land use and production processes to obtain the safe and durable availability of fresh groundwater. Some example. Typically, the physical barriers are physical low permeability barriers, vertical walls that can be realized in different ways, slurry walls, grout cutoff, steel sheet piles. These are the typical approaches in which we create a discontinuity inside the aquifer between fresh and saline water. They were realized in different countries in the world. We are in India, where subsurface dams were constructed using earth material in different sites. With very low cost materials, but there are also other examples. In Japan, were used concrete piles to realize a wide barrier overlapping the effect of these piles. These are the geometrical scheme applied in this case. And there are also peculiar solutions, as in the case in Belgium, where the aquifer, the salinized aquifer, was used to store fresh water and to reuse this during the period in which the demand is higher, typically here in the summer period. Moving to some experience of we operate mainly in southern Italy, in the Apulia region, where very large and deep limestone coastal aquifer are located, are the largest that are available in Italy. They suffered, of course, for the seawater intrusion. This is a section, the aquifer is very large and deep. The depth to groundwater can be also more than 400 meters, for example. But in any case, the approach to the management of this aquifer offers some example. This is the approach to using monitoring. The Apulian monitoring network consider wells, springs, and critical wells. The critical wells are mainly used for polluted areas, so close to industrial areas and urban areas. But wells and springs are of two types. There are equipped wells and not equipped wells and springs. Practically, in the equipped wells, automatic frequently measurements are realized. The not equipped points or springs are used sometimes periodically for sampling mainly. Another approach can be considered the assessment to the vulnerability to the seawater intrusion. In fact, in the case of Apulia region, was observed sampling groundwater everywhere. More than 500 samples were considered. That the variability of groundwater quality are mainly due to mixing between seawater and groundwater mix. Red dots are poor fresh groundwater. The rest, the yellow one and the green dot, are mainly the effect of the mixing. So if we study the red dot samples, statistically we can distinguish a threshold that is typical of this aquifer, of this groundwater, of poor fresh groundwater. The threshold between poor fresh groundwater and groundwater that with a content of saline or marine waters was assessed to 0.5 grams liters. After that, we have used our historical data set to observe the movement of the saline content of the reference contour line, 0.5 grams liters, over the times. And so we obtain a map in which in the green area, the TDS or the salinity was always less than the threshold. So this is the area that in which we don't observe never the effect of seawater. The vulnerability is negligible or very low. In the red area, we observe always value higher than the threshold. In this case, the vulnerability is very high. The rest is the portion of the area, of the region in which the quality, the salinity, is a function of our ability to manage the resource. If you are able to understand the mechanism, the processes, we can obtain very good groundwater. Otherwise, the salinity will worsen. This is the approach based on the vulnerability. Of course, there is no time to show all examples for any types, but if you are interested on more information on this schematization of the worldwide experience on the management of groundwater at risk of salinization, of course, you can find this paper and the relative data set in which all the data, all the paper are listed, roughly 500 articles. Thank you for the attention.
Thank you very much, dear Maurizio, for your interesting presentation. Many countries in the world are facing the similar problem with salinization and seawater intrusion. Now, Professor Karagias and Polemio, please manage the session, calling the participant to present their presentation.
Okay, thank you, Kostas. Dr. Polemio, do you want to start with the first, introducing the first one, which also from Italy?
Okay. I'm glad to call Gianluigi Busico and Fabrizio Rama. The speaker probably is Fabrizio Rama?
No, Gianluigi, if you hear me.
Gianluigi Busico. Okay.
Yeah.
Please start your presentation.
Okay. Good afternoon to everyone. Let me share my screen. I hope that nothing will be wrong with this. Okay. Just can you see my presentation?
Yes.
Yes.
Okay. So again, good afternoon to everyone. I'm Dr. Gianluigi Busico, and I'm a researcher in applied geology at the University of Campania Luigi Vanvitelli. Today, I will show you a case study for the estimation of intrinsic aquifer vulnerability at continental scale, and specifically the case of South America. My colleague Fabrizio Rama, that works for Syngenta agency, unfortunately cannot be today with us for some duty work scheduling. So, as we all know, in the last years, unfortunately, several new external compounds have been introduced in the groundwater body, triggering groundwater pollution. This has unfortunately made this groundwater resource not available for human consumption, with a lot of drawback on social, economic, and environmental point of view. So this is an issue highly recognized also on international community, and as we can see from the Sustainable Development Goal promoted from the United Nations, the groundwater resources are at least involved in three main goals. The necessity to ensure the sustainable management of water and sanitization for all in order to ensure groundwater supply for human consumption, the necessity to manage and somehow protect the water resources from climate change that are going to do, and to conserve the sustainability and the biodiversity of groundwater and surface water resources. And unfortunately, the groundwater pollution is a serious issue that can somehow make not viable all these three goals. So in this scenario, as the remediation of groundwater pollution is highly cost involvement in human and money, the better solution is somehow the prevention of groundwater pollution. And in these cases, the utilization of the assessments of intrinsic aquifer vulnerability is a valuable tool for this purpose. Our main goal for this assessment was the utilization of global data coming from freely available data set to realize a fully integrated groundwater vulnerability using the well-known methodology of drastic method. The drastic method just parameterize all natural barriers that somehow protect the groundwater body from leaching of agricultural activity, that are summarized in unsaturated zone with soil and rock structure, and saturated zone where the aquifer flow also in horizontal way. Why it is necessary? The South America continent is highly heterogeneous in kind of groundwater resources. We have also a lot of transboundary aquifers that are somehow important also for local authority and for local management. Unfortunately, the production of a screening tool as a drastic or other methodology are very scattered and not so rich in South America continent. As we see from the map, we have only Brazil, Chile, Argentina, and somehow Colombia, with at least one or two assessments published in a peer-reviewed journal about vulnerability. Anyway, there are a lot of internal reports in my mother languages that use drastic and God for groundwater management. So is also a tool highly recognized from management of internal reports. But unfortunately, the scientific contribution is very low. So our idea was to build a continental groundwater vulnerability assessment, retaining a resolution of higher than possible. So to allow not only the regional or the national assessment, but also the analysis of farmer somehow and small cases. To do this, we created a conceptual model of the whole continent, schematized here in the aquifer conceptualization, and we collected data from soil, data of soil geology, groundwater depth, morphology, and all the data necessary for drastic elaboration from all global database, from freely available data. They come from shapefile or just raster elaboration, or from groundwater modeling output. And we to avoid inconsistency in data due to the higher extent of the database, we intersected the global data with local database coming from a regional or national local authority, like from University of São Paulo, University of Concepción in Chile, the University of Plata in Argentina, that helped us in discriminate better data and to increase the resolution of the original global database. All this data were so corrected, intersected, and integrated with local data to obtain the much more reliability as possible. As we can see, we created a single map for each parameter. We can see here in the PowerPoint that each one with the spatial resolution of 500 meters for 500 meters, and classified it from very low to high vulnerability. Then, using a spatial raster calculator, we created the final map of drastic elaboration. The whole continent was so divided in 5 classes of vulnerability, ranging from very low to very high. And we see how the higher vulnerability is concentrated around the Amazon area due to the relatively low depth to water table, the really permeable soil and rock saturated zone, while all the area of Argentina, for example, and the upper Chilean mountain chain are classified as low vulnerable, as the main rock formation are crystalline and very not so permeable. After the drastic realization, we did also a complete sensitivity analysis to evaluate the main impact of each parameter. You can see here in the figure A, as the main parameter that contribute to the higher vulnerability of the drastic method are the depth to water table, which hold the maximum value concentrated between 8 and 10, followed by the recharge, also showing a bimodal variation, because the recharge has an heterogeneous spatial discretion on the whole continent, and the topography that somehow influence a lot the whole assessment. In order also to not somehow prefer lower vulnerability to higher vulnerability, we choose to discriminate the distribution of ranges as much as possible as following a normal distribution. Taking consideration that each classes has to be characterized by the same pixel value. After this, to avoid somehow some discrepancy, we made also the validation of the methodology using both a spatial and a chemical validation. The spatial validation was done using 2 case studies previously published in Chile and in Brazil, specifically in the area of São Paulo. As we can see, both the 2 previous applications are perfectly comparable with the new assessment. And despite we are talking about a very small area, the spatial resolution of the new proposed drastic assessment is very similar to the previous one, confirming the utilization of this kind of assessment also for local authority to ensure a groundwater management of the pollution and of soil change and of land use change and planning. Similarly, the spatial distribution of nitrate in the São Paulo area well matched with the rate spatial distribution of drastic, with the lower concentration of nitrate concentrated in the area with low vulnerability and vice versa. We did also a characterization of each South American country according to the class of vulnerability. As we can see, the higher vulnerability percentages are concentrated all in the area of Amazon basin. That is unfortunately one of the most impacted area due to the groundwater pollution, groundwater of exploitation. We have a lot of deforestation that is somehow destroying the natural balance of the area. And this case, this kind of management and the representation of result using a map and symbology that is somehow readable for everyone, well contributed to the concept to make visible the invisible due to the groundwater system and the celebration of the World Water Year of 2022. For everyone that could be interested, the project has been yet published in Science of Total Environment. You can find there the main elaboration and in the Zenodo repository all the data what we use it for as input file and the output, and also the table file with all the file sources that were decided for the assessment. Thank you everyone for your attention.
Thank you for your talk, very interesting experience. I am most curious about this experience, but probably we have time for questions at the end. Do you agree, George? Okay, thank you. So it's the moment to move to the next speaker.
Sure.
George, you can.
Yes, sure. It's Katerini Lira, Athanasios Lukas, Georgios Giagios, Pantelis Sidiropoulos, Nikitas Milopoulos, and Konstantinos Boudouris. And the topic of the paper is intercomparison of water resources management scenarios in Almiros Basin, Magnesia, Greece. And the presenter will be Katerini Lira.
Yes, that is correct.
Okay, please go ahead.
Okay, can you see the screen?
Yes, yes, everything is fine.
Okay, so this is a study that presents the intercomparison of water resources management scenarios for the Almiros Basin in Magnesia, Greece. Almiros Basin is a coastal area in Thessaly, which has quantitative and qualitative problems. The availability and quality of water in the coastal agricultural watershed is dependent on the scarce utilization of surface water reservoirs, the excessive groundwater withdrawals for crop water irrigation, and the excessive fertilization activities for crop productivity amplification. The Almiros aquifer extends to 293 square kilometers. It is under substantial water stress. It faces the problems of nitrate pollution and seawater intrusion. Here in the map, we can see the scenario map we use to simulate the water resources balance. The water resources have been simulated with an integrated modeling system, which consists of coupled and interrelated modules for surface, UTH-BAL and groundwater mode flow hydrology, nitrate leaching crop growth REPIC, nitrate pollution MT3DMS, and seawater intrusion CWAT, and a reservoir operation model UTHRL. In the image, we can see the flowchart of the integrated modeling system and how the results lead to the evaluation of the simulated scenarios. The agricultural water requirements, because it is an agricultural coastal area, were calculated for alfalfa, cereals, cotton, maize, olive groves, trees, vegetables, vineyards, and wheat. Two cases of scenarios were incorporated: the aquifer scenarios, where irrigation happens from groundwater abstractions, and the aquifer reservoir scenarios, where the irrigation happens from both groundwater abstractions and from reservoirs. So as a baseline scenario, we consider the existing irrigation scenario as 0. And as aquifer reservoir scenarios, we considered the operation of 3 reservoirs: Xyrias, Klinovos, and Mavromati Reservoir. The Mavromati Reservoir is intended to supply urban drinking water to 9 settlements, and it has a storage capacity of 1.2 million cubic meters. The Xyrias Reservoir is intended to supply irrigation water, and its storage capacity is 4 million cubic meters, and the Klinovos Reservoir it has a storage capacity of 14 million cubic meters and is also for irrigation. The total irrigated arable land from the reservoirs was examined for 2 cases of irrigated areas, A0 30 square kilometers and A1 17 square kilometers. In addition to that, we studied some irrigation scenarios, the deficit irrigation. Consider that scenario S1 when irrigation happens from the aquifer, and scenario SR1 when irrigation happens from the aquifer and the reservoirs. And then deficit irrigation and rain-fed cultivation. as scenario S2 and SR2. The deficit irrigation is considered for alfalfa, cotton, maize, trees, vegetables, and vineyards, and rainfed cultivation for cereals, olive groves, and wheat. And here we can see in the maps the situation, the status of the quantity and quality in the Almiros aquifer for the baseline scenario S0 at the end of the simulation period in September 2018. We can see that the water table is under the mean sea level in the coastline. We have nitrate leaching that contributes to nitrate pollution, and also seawater intrusion, especially in the northern coastline. The nitrate pollution is evident in the areas with low hydraulic conductivity. And the water resources management were evaluated, scenarios were evaluated regarding the water budget, the crop water productivity, and the economic water productivity. The summary of the water resources management and agronomic scenarios implemented in the Almiros Basin show that the annual water budget is significantly improved in the scenarios where the reservoirs exist and operate, and the crop water productivity is also increased in the deficit irrigation scenario, and the economic water productivity is also increased and scores the best results in the deficit irrigation scenarios. And lastly, the results indicate that the implementation of agronomic and water resources schemes can benefit the water system and local agriculture, especially when the reservoirs can be operated to cover a large proportion of the agricultural irrigation demands. Thank you for your attention.
Thank you. Very nice work. Please stay. Maybe we'll have questions at the end, okay? Or maybe you will have. Okay, Mauricio, you want to go with the next one, please?
Yes, the next speech is from Greece, okay? Christos Christidis.
Hello.
Good morning.
To everyone, for me. It's okay, can you see my presentation?
Yes.
Okay, let's start. So, good afternoon to everyone.
Please put it in the presentation mode.
I show it in presentation right now, isn't it?
I don't know why, but it shows
Full screen, Christos, full screen.
Full screen, yes.
It's on full screen for me.
It is on full
Sorry,
screen,
but-
yeah.
It's okay now?
But go ahead. It's okay. We can see your presentation.
Don't worry, please go on.
Okay, thank you. So the title of my presentation is Delineation of Groundwater Potential Zones in Hard Rock Aquifers in Sithonia Peninsula in northern Greece. Study area is the Sithonia Peninsula, which is a hard rock aquifer system, which occupies an area of 403.4 square kilometers. Because of the intense touristic interest of the area, the needs of drinking water are increasing every year. Geotectonically, the area belongs mainly to the Serbo-Macedonian Massif, which is composed by the Sithonia Plutonic Complex and by amphibolytes and gneisses, the northern part of the peninsula. The southern part belongs to the circumrhodop belt, which is composed by Mesozoic sedimentary and metavolcanic rocks. And finally, a smaller part in the northern...
Christos, please, don't change the slide.
You cannot see my slides?
I see the first slide.
Probably
okay, so
you shared the second screen, not the first one.
Okay, so I will make the presentations, my presentation from here. And finally, a smaller part in the northern, in the southern area of the peninsula belongs to the Paeonian subzone, which is composed by ophiolites and limestones. Sithonia is a tectonic host with north-northwest, south-southeast direction, and it is a part of a bigger transportation zone. The metamorphic rocks of Sithonia Peninsula have been affected on multiple deformation phases during the alpine orogeny, and as a result of that is the extent growth of cleavages, macro and micro faults. During the middle upper Miocene and nowadays, the neotectonic and seismic activity of the area contributes to the extent fracture of the rocks that act as a secondary porosity. Hydrogeological behavior of metamorphic and igneous rocks is related with the discontinuities which created by tectonic stress. In our study, we use Landsat 8 images. Landsat 8 is a program which launched on February 11, 2013, and the satellite achieves an altitude of 705 kilometers and completes an Earth orbit every 99 minutes. It has a 16-day repeat cycle and acquires about 740 scenes per day in the water reference systems. In our occasion, we especially use band 8, which is a panchromatic band with a 50-meter resolution, spatial resolution. From the satellite images, we extract the lineaments of the area, as depicted in the following picture. Lineaments are linear features which act as evidence for the possible tectonic structure, and the extent tectonic structure in hard rocks creates a secondary porosity and the creation of fracture aquifer. The extracted lineaments have mainly directions northwest, southeast, northeast, southwest, east-west, and north-south. We also delineate main tectonic discontinuities of the area as faults and thrusts. The software we used for the extraction was the PCI Geomatica and line tools, and also some GIS software in order to clean the lineaments from the overlying road layer. Finally, we create the fault density map, which is a map that depicts the high fault and fracture density areas, which could be target areas for groundwater. Also, the following picture depicts some existing successful boreholes of the area, which looks like to coincide with intense fault areas and main fault zones. Like in the north part inside this cycle, you can see that most of the boreholes are across the main fault of the area. Those boreholes are over 320 meters depth, and we found discontinuities on them until the 310th meter. Their water supply was between 25 and 50 cubic meters per hour. So we can conclude that the tectonic is one of the main factors for the hydrogeological conditions of hard rock aquifers. In conclusion, potential hydrogeological target areas were determined in hard rock aquifer using satellite images and GIS softwares. And in our next step of the next step for research will be we'll make a comparative evaluation between Landsat and digital terral models lineament extraction and field evaluation for the target areas with geophysical methods. Thank you very much for your attention.
Thank you to you, Christos. Very interesting. Again, we'll try to discuss some more details at the end. The next speaker, please stop your screen sharing. Okay, thank you. George?
Yes, Marie. The next speaker will be from India. We have people from all around the world. It's VK Haritha and Ella Lango, a entrapment of air in a saturated zone and its impact on groundwater recharge. Please go ahead with your presentation. I assume Haritha is presenting, right?
Yes, Haritha is presenting. Can you hear me?
Yes.
Yes.
Please share your presentation.
Okay,
share screen.
Thank you.
Yeah.
I hope it is in the
Okay,
presentation mode.
it's
on
fine.
screen.
We can hear you and we can see the presentation. Thank you.
Okay. Good afternoon, everyone. I'm Harita. I'm a research scholar from Department of Geology, Anna University, Chennai, India. Today, I would like to present a part of my research work on the title Entrapment of Air in the Unsaturated Zone and its Impact on Groundwater Recharge. As we all know, rapid urbanization, industrialization, excessive use for irrigation and deforestation has caused an increased demand for the water resources, and overexploitation of groundwater and subsequent reduction in the groundwater recharge has caused the depletion of groundwater table. And along with the climate change scenarios that is happening in this era, the rainfall patterns have become erratic, and due to that, we are getting short duration, high intense rainfall, and which has caused increased runoff and erosion. Another one problem that is faced is the entrapment of air in the unsaturated zone during infiltration in the shallow water table aquifers. That is, during infiltration, if the wetting water front pushes the air in the unsaturated zone downwards, and if the air pressure is larger than the water pressure of the wetting front, it will create an air entrapment in the unsaturated zone. This that entrapped air will hamper the infiltration rate. That is infiltration rate. So that is, the infiltration rate will be affected by the entrapped air in the unsaturated zone. I would like to bring your attention to some of the previous researchers where they signify the influence of entrapped air in the infiltration. It had been proven that the magnitude of air pressure buildup is on the order of tens of centimeters of the water column, and if the air can easily escape to the atmosphere, the impact on infiltration can be ignored. That is, if there is no effect or minimal effect of entrapped air on the infiltration rate, there will not be any impediment to the infiltration rate. And when it comes to the column studies, if the column is closed at the base, it will take 10 to 100 times longer to wet the columns of silica sand. So for tackling this issue, that is to facilitate the removal of entrapped air to increase the infiltration, we have come up with an idea of soil ventilation where it will provide an easy flow of air to the atmosphere, and subsequently we can improve the groundwater recharge. This is the concept that I have just told now. That is, if that is during ponded infiltration conditions, if the water table is shallow enough, there will be entrapment of air in the unsaturated zone, and if we are providing simple pipes as ventilations in the unsaturated zone, that will provide an easy way for the entrapped air to escape to the atmosphere, so that we will get more room for the water to get accommodated in the unsaturated zone. Thereby, we can increase the infiltration rate and groundwater recharge. For conducting this study, we have conducted a laboratory sand tank experiments where the dimension of the tank was it was a 40 centimeter square column with a height of 60 centimeters. Here, the column was closed at the bottom and open at the open at the top, and we have provided an outlet pipe up the base for easy drainage for drainage of the water after each successive experiment. In the bottom 4 centimeters, we have provided it with fine grained gravel for easy drainage, and from 4 to 40 centimeters, we had given a medium grain sand in the column. In the column, we had conducted ponded infiltration experiments. We used to pond the column by around 10 centimeters, and we used to measure the infiltration rate. A piezometer was provided in the column for measuring the water level rise in the column, and we have provided simple pipes as plexiglass tubes as ventilations in the column. We have conducted experiments without vents as well as providing vents of 1 to 5 numbers. Since the experiments were conducted manually, so that we have repeated experiments multiple times, and as a whole, with and without vents, we have conducted almost 250 experiments. The results of the experiments were analyzed for statistical significance, and you can see these are the box plot for the experiments conducted. from without vents as well as from 1 to 1, 2, 3, 4 and 5 vents. With each we have conducted this much of experiments with each number of vents. In the y-axis we have given the infiltration rate, and if you can see without vents, here we have provided for the infiltration rate at each 10-second intervals from 10 seconds to 50 seconds. Here you can see, if you look into the box plots, in the very first 10 seconds only, we can see a broad range of infiltration values, and if we go across from 20 to 50 seconds, the range is comparatively narrow. And one more thing we can notice is that from no vents to 5 vents, if you see, there is a significant improvement in the infiltration rate. That is, with no vents, we can see the infiltration rate was around 1.2 to 1.4 millimeter per second. And if you see here, we can see an improvement in the infiltration rate for around 2 to 2.5 millimeter per second. In this figure, we can again see this rate in infiltration in detail, where here we have compared at each 10-second intervals with increasing the number of vents, how the infiltration rate has changed. And if you see, from no vents, this blue is for the no vents, and this is for 1, 2, 3, 4 and 5 vents. If you see, in each 10-second intervals across the plot from no vent to 5 vents, there is a significant improvement in the infiltration rate. And even at 50 seconds, that is during the later stages of the experiments also, we could observe that effect of ventilation in infiltration rate. This table shows the mean infiltration rate for the whole experiments conducted, and here in this blue we have signified the percentage of increase in mean infiltration rate compared to the no vents case. Here you can see, with the at the 10-second intervals, with the provision of just one vent itself, we could see an improvement in infiltration for around 42%. And when we go down the column, if you see from 1 to 5 vents, that how the infiltration rate has improved, and for 5 vents, we could see an improvement in the infiltration rate of around 88%. And if you see in the 50 seconds, from we could see an improvement from 24% to 53%. Here I have given the variance and the percentage of variance of the mean infiltration rate. That is infiltration rate from the mean infiltration rate. If you see the variance percentage also, it is very minimal, except in the one vent case. That is, maximum variance we could observe was around 8%, that is 7.78%. In all other cases, it was around 1 to 3. The variance was 1 to 3%. So I would like to summarize here as with increase in the number of vents, the infiltration rate increases, and infiltration rates can be increased from 40 to 90% by providing ventilations. That is, the insertion of simple pipes in the unsaturated zone as ventilations facilitate the release of entrapped air, and it improves the infiltration rate. Consequently, this will help in reducing the surface runoff, and thereby discharge in the stormwater drainage will be reduced, and thus it can even mitigate flooding. That is, if we are providing more room for the water to accommodate in the subsurface during the high intense rainfall periods, the runoff can be reduced, and we can store maximum water in the subsurface. That's it, and I would like to acknowledge Department of Science and Technology, Government of India, the Inspire Fellowship, for funding this research. Thank you for your attention.
Thank you very much for your interesting presentation. And let's move to the next presentation, which is from Brazil. Mauricio?
Yes. We have two authors, Milene Guerra Lima Sugui and Claudio Antonio Di Mauro. Probably there is Claudio or not. The next speaker from Brazil, please.
Is anybody from Brazil?
It is early in the morning in Brazil now, probably 9 a.m.
But I assume they are aware of the time, right?
we can move to the next speaker,
Right.
and in the case they will connect, we come back to them. Okay, George? The next,
Sorry
you can
for,
go ahead. Go ahead with the next one.
there is someone speaking?
yes, sorry for interrupting you. Claudio was signed in earlier. However, he's not here right now.
Oh, okay. Okay. So
Yeah, but we cannot do much, right?
Mhm.
okay, we move to the next speaker from Nigeria. We have two authors, Omowumi Ademila and John Olukunle Ademila. The speaker is, please, is connected from Nigeria.
I think the presenters are not here. Maybe we have only the last presenter from Greece, Alexandra.
We can go the last presentation.
Okay. Alexandra, probably.
They should be here. Yeah.
Hello. Hello.
Yeah, Alexandra Gigagios, Katerini Lira, Pantelis Sideropoulos, Nikitas Milopoulos, and Athanasios Doukas. Please, Alexandra, go ahead, share your screen.
Is everything okay?
Yeah.
Okay. Good evening. I'm Alexandra Zika, and this study is about groundwater vulnerability assessment using the drastic method in the Lake Karla aquifer. The augmentation of human population with the increase of agricultural activities and the excessive use of fertilizers, along with the climate change, are contributed not only to the reduction of available water reserves, but also to the groundwater quality degradation in many regions of our planet. This deterioration of groundwater level and contamination of available groundwater resources have increasingly become serious issues. Hence, there is a need to study this indispensable resource in detail and the vulnerabilities associated with it, so that preventive measures can be anticipated in advance. The prevention of groundwater pollution is essential, especially when an aquifer is more vulnerable to contamination and, of course, where there is water scarcity. To tackle these issues, an assessment of groundwater vulnerability is the most feasible step for preventive purposes of contamination of groundwater, especially in irrigated and cultivated areas as in Mediterranean region. The study area, the aquifer of Lake Karla basin, is located in the southeast of the water district of Thessaly in Greece, covering an area of 500 square kilometers. Most of the aquifer area is plain, and with agriculture being the main economic activity, there is an increasing water and fertilization demand, which has led to an overexploited aquifer and to nitrate pollution of groundwater. In this study, an attempt was made to delineate the vulnerable zones to potential pollution of the aquifer of the catchment area of Lake Karla using the drastic method. The acronym DRASTIC incorporates the major geological and hydrogeological factors that affect and control groundwater movement, so as groundwater pollution. So it is D for depth to groundwater, R for recharge, A for aquifer media, S for soil, T for topography, I for impact of a door zone, and C for hydraulic conductivity. The model yields a numerical index that is derived from ratings and weights assigned to the 7 model parameters. The weights are given to each parameter relative to one another in order of importance, 1 to 5. The higher weights representing greater pollution significance. The classes of each parameter represent the ranges which are rated from 1 to 10 based on the relative effect on the aquifer vulnerability. Rating 1 is the least contamination potential, rating 10 the highest. The drastic index, the I, is then computed applying a linear combination of all factors according to the presented equation. The higher the I number, the greater is the relative groundwater contamination potential. For this study, to estimate the groundwater vulnerability to potential pollution, water table data, climatic data, hydrogeological, geomorphological, and soil data have been used for the hydrological years 2004, 2007, and 2015. Using the GIS service ArcGIS, the maps of the 7 conditioning factors of potential pollution have been used to prepare the synthesis of the vulnerability zone mapping of the Lake Karl aquifer. The vulnerability map was generated with the integration of all thematic maps of each parameter. The presented map is the vulnerability map of the Lake Karl aquifer for the dry period of 2007. According to the delineation of vulnerability zones of the study area aquifer for the dry period of 2007, around 56% of the area is in the low moderate vulnerability zone and around 18% shows moderate and moderate high vulnerability, while less than 10% is in the low vulnerable zone. The northeast and southeast part of the aquifer are moderate and moderate high vulnerable to groundwater contamination. The results divulge that there is an urgent need to face groundwater pollution and the anthropogenic activities that cause it. The vulnerable areas of the Karl aquifer indicate where protection measures of water resources must be implemented to safeguard the aquifer's water quality status, especially from nitrates. The prevention of nitrate pollution while ensuring the sustainability of the Karl aquifer can also be achieved with the application of good farming practices. Thank you very much for your attention.
Thank you. And Mauricio, I think we have all the presentations for this session.
Yes.
Except if we have someone who was not here before, if he has shown up now. Is anybody for the paper from Brazil or from Nigeria?
No, probably no.
No, probably not. Yeah, no, it seems like nobody. Therefore, we can go to the discussion part.
Yes.
I think we have some time to discuss some of the presentations. Should we see if anybody from the audience wants to ask something before we go?
George, there are some questions from you in the
Okay. Is the chromium meant as a tracer for human population, or are there also significant impact by geological formation? By the geological formations, the impact is not significant. The impact of the chromium is mostly from the industrial area, where the concentrations go up to 10,000 milligrams per liter. Now, regarding the geogenic part, where then there is a problem if the concentration goes above the 40 milligrams per liter. So in these cases, we should avoid getting water from these areas, or because, as I said, the concentrations are high enough. But as I said one more time, the big problem is in the industrial part. There is another question by Jason Gabriel Pinza. The occurrence of chromium-6 appear to be localized in the contamination map. Is it due to local occurrence of ultra-basing rocks nearby their hotspot that contribute to the leaching? Were there any outcrop of this? Yes, the green colors in the most area where we have up to 100 milligrams per liter is, as you mentioned, is due to the geogenic pollution, and you mentioned to ultra-basing rocks. It's that part of Greece which is characterized by the existence of ultra-basing rocks. And the next one is, where do they occur? In porous media or in fracture hard rock media? No, it's porous media. If the area is characterized mostly by porous media. Concerning his opening presentation, is the chromium meant as a tracer for human pollution, or are there also significant impact of the biogeological formation. As I mentioned, it's not tracer, it's a biogeological formation. And also, now it's going to Ekaterini. How about groundwater quality? How will you measures improve it?
Caterina.
It's the second presentation from Greece. Katerini Lira, do
Yes.
you want to answer that question?
Yes, yes, of course. So how they prove it? In all scenarios, when the irrigation is reduced, the groundwater abstractions are reduced from the aquifer, the groundwater quality improves and improves significantly for seawater intrusion, especially in the coastline area. I didn't have time or space to place some maps there. And in the deficit and rain-fed scenario, the seawater intrusion is reversed. It doesn't happen at all in the coastline. And in general, they improve the groundwater quality, all the scenarios. But even if we run the model for 28 years, I think, the groundwater quality still doesn't reach concentrations that are acceptable for drinking water. So I guess it's good to implement deficit irrigation and rain-fed and construct reservoirs to irrigate. The contribution of reservoirs is very significant. It's especially in the water budget that is evident. But maybe additional actions are required in areas of the aquifer. But in general, they have a positive impact, all the scenarios, in the economy, in the groundwater quality, the groundwater quantity, everything. I hope I've answered the question of
Yes, since we have you here, also, you have done a very good work and very complicated because you have used several models. It's not easy to combine all this stuff. And I had a thought, maybe also, but I'm not sure how easy can be performed, a cost-benefit analysis to do. It's because yes. Also the building of reservoir or having more wells or things like that, maybe it's also decision-making.
It's a good idea. I will think about it.
Just an idea. I'm not sure because you have too many models and very complicated.
Yes, many models, many indices, many results. But it's a very nice idea. Maybe
to introduce
for
also
work.
Cost.
Yes.
Yeah. Okay.
I will think about it seriously. Thank you very much.
Thank you. Then is another question. Are there easy ways for the industry to remove the chromium from the wastewater? Yes, there are several ways to do it, but the easiest way was to throw it or to dig the wastewater into the ground or supply them through a well into the ground. That's their mistake, and that happened for many years, not for 1 or 2 years. The industrial park has been there for more than 30 years, and several companies passed from that. It was not the same company all this year. The thing that they were not doing any removal of chromium from the wastewater that they had, or in general, the waste, any kind of solid waste or water waste. Could we get copies of the presentation? Maybe Professor
a question for the organizers, please.
Yeah,
for the organizer.
They have to make the decision. Maurizio, we cannot answer that question.
Yes, of course.
Costas, what do you think? Can they have a...
We will discuss in the organized committee, we will discuss this issue. Maybe if the authors agree, we can upload the presentation. I don't know exactly.
Okay.
Yes, it is reasonable.
Mm.
Yeah, yeah, yeah. I think now, do we have any other questions or anybody wants to answer directly the question?
A question for Gianluigi. I'm a bit curious about the application of vulnerability method to this very large scale, continental scale. Usually we use this method at the detailed scale with a lot of problems concerning data collection on site and the accuracy and so which is your experience, the critical difficulties that you have found in this case operating to the continental scale? Gianluigi.
Is he online?
Is online? Yes, I see, but the microphone is turned off.
Maybe,
can you?
maybe he's online, but not in his office.
Probably. Okay.
There is another question for Alexandra. It was the last presentation, and it's from Jason Gabriel Pinza. Thank you, Jason. Very good questions. Thank you for participating with that enthusiasm. To Alexandra, are the anthropogenic activities the main contributor for causing high vulnerability to any NSC of your area? How about natural factors, e.g. geology?
It's not the anthropogenic activities that cause this high vulnerability to this part of our study area, but yes, it's the natural characteristics of the aquifer, and it's the depth groundwater, the factor that gives us these results, and of course the recharge. But drastic method surely has its disadvantages as a method.
Okay, thank you. I have a question for Haritha. Haritha, very interesting, the methodology that you proposed. Have you gone to a large scale now, or do you have any idea how it can be applied to a field case?
Yes, we have already conducted a field experiment. We are going for the large scale, and we are trying to do a numerical model as well. So we, like as in we can do and how it changes in a small basin scale or a region scale. As of now, we have conducted a field experiment. Though the results are not significant as in the laboratory, still it is working. But not in conditions where there is clay, there is presence of clay or very fine silt or fine grains. It is not so working because it's so difficult to come out, come out. But in medium grain sands and fine to medium grain sandy aquifers, it is working. But since it is not as working as in the laboratory conditions as it is controlled, because we have so many constraints in the field, but still it is working, and especially in areas where the frequent flood is occurring, and whether the water table is around maximum, if the water table is 10 meters, this will definitely work. Beyond 10 meters, there won't be much air entrapment.
Right, right. Do you think that
there is another question also, a written question?
There is another question, Mariti?
Yes, it's written.
Okay. A question to the presentation with the salinarity of the first water aquifer. What kind of problems, solutions can result by this process of mixed water bodies? I think it's for you, Mauricio, right?
Yes, but before there is one, another one for.
Question to the experimental study about the infiltration and air content.
Yeah.
How is the expected outcome for
Anita.
different soil types, and how will the ventilation work apply in the field? I think you answered some of that question, Carita. If you want to.
Yeah, let me see the question again. I'm not clear about it. What was the question? Are there?
It's an anonymous attendee. Do you see the question?
No.
It's in the chat. Oh, no,
Okay.
not in the chat, excuse me, question and answer. Press that
Okay,
button.
let me see, okay.
It's the one before the last one.
Okay. How is the expected outcome for different soil types? How would the ventilation work? Okay. So in the field, it's different, but many conditions we cannot control, and in the underground, if we are covering it, if we are conducting it in a pond or in or if we are digging some pond, if we can control the lateral sides of the pond, we can see much results. But if in the field condition it is much more open, so that the experiment, it won't be much significant as the results we see in the experimental column. And with the different soil types, if the aquifer is having a coarse grained sand, there won't be much air entrapment. And in fine grained aquifers such as clay or fine silt also, there will be air entrapment, but it would be difficult for us to take the entrapped air out, so that mostly it will be working in sandy aquifers.
Okay, please, Anita, greets the Professor Elango.
Sorry?
My greets to my salutation to Professor Elango.
Oh, okay, sure,
I tried to come in your city some years ago for the Indian groundwater conference, but the town was completely flooded.
Okay, back in 2015.
Yes.
Yeah.
It was the most dramatic experience. In any case, please give him my salutation. To answer, I try to answer thank you, Anita. I try to answer to Lucas. He wrote about the salinity and the freshwater aquifers. He wrote what kind of problem solution can result by these processes of mixed water bodies. The problem is, of course, the reduction of quality due to the increase of salinity up to level that can be reduced the use of this water for agriculture, but also for drinking purposes. The solutions are very wide. I try to summarize in a figure. There are tens of types of solutions. Generally, these solutions are selected is wide and huge is the problems observed with the reduction of salinity. Is too complex to summarize in one answer all the wide range of solution. I suggest to read this paper that is a review full of reference to national experience. I will pass the link to the paper, and if someone has difficulties to the free discharge of the paper, please can also write me to in this way I will send a private copy directly. But there are a lot of usable experience worldwide. We tried to discuss all together, create a schematization of approaches that can be selected to apply the best solution to the peculiarity of each area of each country.
Maurizio, do you use any kind of model for the saltwater intrusion to predict situations?
The experience of my research group, we use generally mud flow and seawater and fair flow.
Right.
But prevail mud flow and seawater. Also for the limestone aquifer, because in our case are very large, so the difficulties to describe the very wide variability of hydrogeological values in the case of karstic are reduced because we works on management and so regional situations.
Yeah, we have been using FEFLOW and but also ModFlow, but also lately we found the FEFLOW model it's more complicated, but can handle double density flow. You can yeah, but it's not easy. I mean, you need a lot of time to calibrate the model.
In practical terms, we have a narrow experience with FEFLOW because it's difficult to collaborate with others, to exchange experience or models due to the limitation of the license.
Yeah, yeah. And there is another question for you. Is the salinar mixing a big problem or it is a quite local process?
It's a big problem, especially in my region. There is not so time to describe, but there in my region is long 400 kilometers, and we have no rivers due to karstic features. So we need to tap groundwater more or less everywhere in the region. And also these aquifers are coastal, are under effect of the seawater intrusion, especially the southern part of the peninsula, the Salento is called, is like an island practically, with the water, the seawater on three sides of the area. So the problem is very, the seawater go from the side to the other, from the Adriatic Sea to the Ionian Sea.
Yeah, and it's very difficult in the cases where you have karstics. Karstic is a big problem to describe the flow or to see what is going on.
Yes.
It's a little bit chaotic behavior.
Probably there is a new speaker connected.
Yeah, we can see the presenter from Nigeria.
Admira.
Is he here?
Yes, I can see them.
Okay. Does he want to go ahead and make the presentation?
Turn on the microphone, Admira. Admira, the microphone.
Please turn on the microphone. You are muted. I'm not sure if she can hear us.
We don't hear.
Demila, can you hear us? Can you hear us?
Turn on the microphone.
I can hear you.
Okay.
Yes.
Do you want to make your presentation?
I have a paper to present.
Are you ready to present?
Yes, I'm ready.
Okay. Can you share your screen? You open your presentation and share your screen. Do you see share screen on the bottom of your?
Yes.
It seems like it looks for your... Yes, yes, go to the first slide. Yes, good. We can see your presentation.
Move to the first.
Yes.
Go to the top of your presentation. Yes, good.
Yes, this is the first page.
Okay, we are ready.
Good afternoon. Yes, good afternoon.
Good afternoon.
Dr. Mrs. Demila.
Please start.
Omoni.
Okay,
The quality of connection is low.
yeah, now it's better. I think someone had the microphone on, Mauricio. It was not from her.
Yes, but the symbol of the connection was red. They had problems with connection. Is the quality low?
You think we lost connection? Ademila, can you hear us? Let's see. Let's wait and see, but there is another question from Gianluigi. Gianluigi.
But Gianluigi...
not around.
Yes, yes. Probably we should stop here because...
Yes, Mauricio, I agree. Thank you very much, all the authors, all the thank you very much, all the authors and participants. Thank you very much, Professor Karagias and Dr. Mauricio Polemio for mentoring. I believe it was a very, very high quality scientific session concerning the groundwater. The discussion is very, very fluid. Thank you very much.
Thank you.
Thank you to you. Thank you to all of you.
Bye-bye.
Bye-bye.
The next. Bye-bye.
To next session.